Epa, Epa, Epa. You have appeared here first. Oh, yeah. IJ. Just logged in and went left. Can you hear me? No, I can't hear you. I can't hear you. Is your speaker? You need to. Is it Wala? I know, but work on your. I think your speaker has, or your. I don't know. Check your connection at this before we start. Check it. It is well. Enemies. Enemies at work. But see whether you can log out and come back again. See if you can go and come back again. See if it will work, or check your connections. Okay. My daughter is answering you. Abi? Okay, no wahala. Cheers. Yes, so greeting you.
Hello. Hello.
Good afternoon,
Hello,
Dr.
sir.
Francis.
Yeah, good afternoon. Yeah, good afternoon.
Good afternoon, Dr. Francis.
Yeah, good afternoon, guys. My apologies. I'm just even getting back. All right. Where did we stop last? So where did we stop last?
I think we stop on the libraries in R. We talk about
Oh, okay, yeah. Zipline and
tidy
Tidy
fans.
Bed. Have we installed those packages now?
I think
Yes,
it's only
I
one person. Okay.
Oh. So the remaining, you guys have not yet installed it. Because those are libraries that you actually know you are working. Just like you have pandas now in Python now. So that's the
We have installed it. It's only one person that has not installed it last week.
okay. Great. So we know how to import data into R, right? We know how to assign variables in R.
yes.
We know how to combine data,
Mm.
right? To combine your data, your vectors, right? So for example, if I had something like, let's say A, maybe A, so you have to now combine, let's say we have 20, we have something like this. 15, 14. You have something like this, isn't it? So you can just combine them together. Can you see that? So you can have that for different lists that you now combine all together. Because sometimes when we are extracting data, they may all be unstructured. So we have to put them in a list, in a vector like this. Then now what? Combine them in form of what? A data frame. So that's what we're trying to show, that you can also put them in form of data frame. Let's say we combine and that set again. Let's say we have this one will be let's say different names now. This one will be Francis, it can be IJ, this can be Lukman, this one can be Vivian, isn't it? So this how many we have? 5. I mean 1, 2, 3. So one, let's say Moses. Let's say another one is Moses, isn't it? So we have B now. Okay. So we can now what? Combine them. So how do we combine them now?
Data frame.
Yeah, maybe we can put okay. Let's say df is equals to what? Data dot frame.
Data frame.
You know, then I want to combine it. What am I combining? I'm combining what? B, comma what? A. So df. Can you see that it will list everything now in one column? But if I want to put them in a table form, isn't it? So what do I do? I do the same thing.
Fine.
Yes. It will be what? Data frame. So I want to put in like an independent data. Yep. So I'll come and put B, comma what A. So I want to combine them like in rows and columns, right? So we have something like this, isn't it? So that's why it's important that you see before you do all this, you must label your variables properly. So here I would have put here as maybe score. Then here I would have just put as names, isn't it? So that when I'm running it, it will just I'll come here. Let me change here to names. Let me change here to score. So that when I run it now, I will see them here, isn't it? Otherwise, we'll not have to go and rename it again. So that way, it's good that you give proper names, isn't it? Then if we want to turn it, if we want to unpivot them, how do we unpivot it?
Use stack.
Stack, isn't it? So for example, if I have df is equals to stack df. So if I run df now, let's see. Df. So you don't see how the structure will look like, isn't it? But remember, because this one is just trying to turn them, but this is not how the data will be. So for example, if we had a which one did we use that day? Okay, but the point here is just that how is going to turn them. It's not you have the names one side, you have the score on that side. If in case you need to put them on pivot, then okay. We have also shown how to import the data, right? We have shown you how to import what data. So if I was to import any data now, how will I import the data?
Go and look for the path.
Yes, go and look for the path here, or I will just come to my import data. Let me see, do I have any listed there? Okay, let me use the one. Okay, let me look for one that we can use. Okay, let's say for example that superstore. Okay, let me try and put that superstore. So I come here, import. So that's you need to be sure what the data is. Either it's Excel or it's CSV. Can you see text? CSV is text. Read R. Okay, so if I say read R, so I'll go and choose the file paths. Let's say it is under R. No, this one. So let's say we have okay, superstore. Okay, let's say superstore. So you can see the data here, isn't it? So if you want to change the name, so this is where the name is. So if you have it like this, what do? You just want import. Okay, so that's the data. So what you'd have had in Excel, this is how it is now, isn't it? This is not how you have the data in here. Okay. So normally again, so it means that if I want to bring in a CSV file, what do? I'll say library. What's the name of the library? Read R. So this is to read what? CSV files. Okay. So if I put df equal to read. Now you see what we were doing before, we would have used read Excel. How are we reading Excel file? It would have been read Excel, isn't it? Now we can also do read CSV. Okay, even sometimes it can be read.csv. So you see that you can have these two. Okay, so if I say read underscore CSV, then I know the file path. If I know the file path, I will just go and copy the file path, copy that file path, and paste. Okay, but remember here you are expected to what? Change the slash. I think remember this one. So you have to always change that this thing there, okay? So if we are done with that, okay, so if I type df, what does it say? It's not reading it out. Okay, now let me say view. So if I want to read everything, view. Yeah, but that's it now. So that's just it. Okay, so that's one way of bringing it. Let me see it now again. Read.csv. I think read.csv should also work. Let me say df1. Okay, say df1. If I say view df1. All right, that's it. So you see, there are two ways we can do it: either read_csv or read.csv. Okay, so this is how to read the CSV file. Okay, that's how to read what a CSV file. And just like your, Python that you read them in index 0. Okay, this one usually index is 1. So for example, if I want to see the names of all my columns, if I just say names, what's the okay, let's say df1. Guys, it will list all your columns. Can you see all your columns now? It will list all the columns. But there's one interesting thing that happens here. If you look at the original data, you will notice something that is happening. In the original data, you'd have had spaces here like postal codes, product ID, right? Or that date. You would have noticed that you'd have had spaces. But you don't see that you join those spaces together and put a dot there for you. Do you see the difference now? It will bring it like this for you. If there was, I've checked the original data, you may see spaces. Okay. But you now notice that you bring them together and put a dot for you. Okay, it will put a dot for you. So because normally you're not expected to have spaces, isn't it? But now it's going to join them for you. So that's the advantage of this. Okay. Otherwise, I put them either in brackets. Okay. So if you want to see the data type, you say string, what's the df1. So you can see all your data types. So you can see these are characters, these are strings. So when you see CR is character, int, integer, right? Character, integer, number. So those are how just to check their data type. So if you want to see the number of rows, n row, df1. So that's to check the number of rows. So if I was to check columns, n columns, df1. So that's rows and columns. Okay. And remember, it's going to read this row by what? Column. Row by column. So normally, if you are reading, maybe let's say, for example, let's look at the original data again. So these are the columns, right? So these are my rows. So let's say I'm looking for 1, 2, 3, 4. Okay, let's say first 10. Now remember that it's going to be reading it like row by column, right? Row by column. Let's say df1. Let me put 1 there. Can you see what it's doing there? df1. So you see how you just like you slice in Python without your bracket, isn't it? So can you see that it's giving me the first column? The first what? Column. Okay, the first column. So if I say, so you remember that this is going to be reading it row by column. Okay, row by column. Okay, so the first one is the row, the second one is going to be column. So if I have df1, if I open brackets and I say 1, 1, Can you see that? First row, first column. First row, first column. But if I say 2, can you see that? It will be picking it that way for me. So which means if I want a range, so give me the first 10 rows and give me first 2 columns. First 2 okay, let's run it like this first. Can you see that? This one will give you what? 10, is it not? So let's count. So this will give you up to how many now? Let's see the original data so that you see what's speaking for you. So we said look for what? So you see what is speaking for you now, is it not? 1, 2. Okay, it's even going down this way, Seth. Okay, can you see it's going to the second column? Can you see that? So this is give me the first and second column. So that is the second column you are seeing here. Can you see that? So this is how you normally slice, just like you have in your Python. So it means that if I want to get the first 2 columns, now what do I do? 1 to 2. So this is first 10 rows, first 2 columns. First 10 rows, first 2 columns. So can you see that now? So this is how you are going to be slicing. Okay, so this is how you are slicing it. Okay, so row by column. But if I put a comma there, that means give me all the columns. This one means give me what? All columns. Can you see that? It means give me all columns. If I do it the other way, give me all rows for the first 10 columns. So that's the difference. This is first, give me all the rows, but first 10 columns. So that's how it's going to be arranged there. Is that clear? So it means that I can go deeper and say, okay, GF1, let me get, let me say the first 50 rows. First 50 rows. Maybe give me the columns 18. How many columns do we have? Let me say, give me column 10 to 19. Let's say 10 to 18. Then I can just call this one data. I can just assign it into data. So if I say view data. So can you see that now? So that's how you would slice and pick. So once you have collected the data, you can easily walk around it to pick your data. Okay. So that just basically is about your data. Okay. All right. So that's basically it about. So are you clear with this slicing? How to slice your tables now? Are we clear with this?
Yes.
All right. Great. So that's slicing. That's slicing. Okay, slicing. So because another critical aspect of your as data analysis is you have to be working with the libraries, which is your tidyverse. So for example, you have what they call, so if I just say n rules, or if I say names of data, that will list the columns for you. There's another one that has what they call column names. Column names, let's say data. Can you see that giving you the same thing? So either names or what? Column names. Okay. Either names or what? Column names. Then another aspect again, if you want to still slice them now, but you want to filter. So if I also filter this data, how do I filter the data now? If I also filter the data now, how do I filter it? And also filter this data. How do I filter it?
I think you use and then, I guess.
Yes.
So you say and
Piping.
you can say select whatever you want to
Select, right? So let's say we have okay. Let's say DF. Let's assign it to DF, right? So DF what now? So let's look at this data again. Let's look at data. So this is the data, right? So I want to filter, I want to get only south. I want to get only south. Only south. Give me data for only the south. So let me see data for only south. So how will I do it? Only south. How do I get data?
And say select
Uh-huh.
the data, that table, and then filter only south, something like that.
Okay. Normally, right, I will have to call the entire. So let's look at the column names now. So when I run this, right, these are the column names. So let's say, for example, I want to see maybe the region, let's see the category, product name, sales, and quantity, isn't it? So if I am to do that, I will have to say data and then, is it not? So I'll pipe it. You know how to, what shortcut to pipe?
That's
What
a
shortcut to pipe?
percentage.
Control Shift N. Control Shift N.
Okay, Control Shift N, yeah.
Yes.
Control Shift F, yeah, that's
yes. Okay. So that's the data, isn't it? So we want to so that okay. And then so just like saying okay, let me pipe it there. And then what? And then I want to select now. I want to select the specific word columns. So which column do you want to select now? Let's say we want to select region.
Region.
Remember, it is very case sensitive, so you must select it the way it is. Category.
Category.
Let's say okay. Let me just let's just say sales and let's say sales and quantity. I think that will be fine. Sales and quantity. Okay, and then what do I want to do? Now I want to filter. Filter what now? Where what region is equals to what? Is it south? So let's say where region is equals to south.
South.
Let's see if it will work. I say could not find error in data. Space there. Let me see. What is the error there now? Could not find function. Hey, look at it. Could not find function type. So why is that so? Could not find function type. Why is that so?
I think you need to view something after the filter.
Now I say could not find the function, this function to type. Why is that so? Why is not seeing it?
Okay.
Yes, why is it not seeing it?
I don't know. Is it? I don't think space matters, but there is the beginning of the statement, the piping function. There's no space between data and that. I don't think it does matter. That's the only thing coming to mind right now.
Now, you do not just type it that way because this pipe is a function which is inside the library. Do you get? Okay, so it means for it to work, you must bring in the library.
Oh,
So if I
okay.
say, so I want to call the library, and I say library, let's say deep, deep layer, like this. Is that the spelling of it?
Yeah.
Deep layer, right? Now remember that if I just run it this way, right? If I run it this way, it may still work, but you see situation where you have to also see some people, they still put it inside their. Can you see that? I'll put it that way. Now let me run this one and check. Now will it work? Did it work?
There's an error in filter.
What did he say?
Oh, okay. The equality sign.
Yes,
Comparison
exactly.
sign.
Because it's saying where is equal to that. Good. So did it work now? Has it
Yes.
worked?
Yes.
Good. So you see, before you use this pipe, you must call the library. You must call the library. Okay. So now we can view. So let's say view DF. Can you see that now? Now it has brought
But
it up.
are you using a different laptop today, or you had gone to uncheck that? Because it wasn't. You did it the last time without calling any libraries.
So I called the library. I called the library.
Oh, really? Okay, I missed
Yes,
it.
I should.
But is it possible to have the? Okay. Okay.
I showed you now. We have to call the library. I brought the deep layer. I also brought ID pass. Okay.
Yes.
Then another thing we must take note of is this one. 1 equal to is an assignment. This one is comparison. I hope you remember that. That this 1 equal to is to assign. Is it not? Assign. Why this double equals to is what? To compare.
Okay.
Check if they are what? The same. Isn't it?
Mm.
So you check if they are what? The same. So remember again that where you are working with 2 columns, right? So let's do the same thing again. Let me call. So if, for example, you say region and okay, let me look at different columns now. Let's say column names for DF. Is it name or names? So we have region category. So let me see what we have in category. Okay, let me call the data again. Let me see what we have in category. Okay, let's say furniture. So I want, let's say, West and furniture. So extract for me West and furniture. Isn't it? So whenever I'm working within 2 columns. Now let's say, for example, I want to work with 2 columns now. West and furniture, right? Which means category is furniture, right? So I will say and, or should I do it in a new column? Or should I write another line again? Let's say data. So that's data already. So let's call it data 1. Let's assign to data 1. So we have data. So let's, and then what do you want to do with data? Select. What am I selecting? I'm selecting the region. I'm selecting the category. I'm selecting the sales. And I'm selecting the word quantity. And then what? And then filter. What am I filtering? Where region is what? Let's say West. And let me not close it yet. And what? Category. And category is equals to what? Furniture. Furniture. Please confirm that my spellings are correct. Okay, furniture. So when I'm working with two columns, I'll use what? And. Is it not? When I'm working with two columns, I'll use what? And. Okay. And furniture. Okay. So did that work for us now? Has that worked? So if I say view data 1. So did it work?
Yes.
Yes, good.
It worked, right? Great. So all these are different ways of now what? Selecting your data, because sometimes you may want to select a group of data so that you can easily work with. And now for R, for example, if I was saying, let's say I wanted to do the same thing here, right? So I want to select maybe west, or let me see, GF1. Let me clean that one. South. So let's say south or west. You know how you'd have done it normally? You'd have said south or region, is equals to west. Or region is equals to west. Now let us see now. You will notice that it doesn't understand this or, isn't it? It doesn't understand this or. So it doesn't understand or like this. So rather, I think we will use this. You know, when we're doing the Power BI, right? You remember how Power BI, how it sees or? Or is what? This slash, isn't it? You do double slash. Why and is this double? In DAX. But you see, in R, this is or. Why and you just use one ampersand. Okay, so that's just it. So if I view it now, let me run that now. So can you see that it's south or? So when you are working within one column, I want to pick within one column is this or. But if I'm picking between two columns, it is region and. I hope you remember that. Do we remember this?
Yes.
Yeah, okay, great. So that's how you are slicing them and picking out the data. Because it's going to get to where we need all these things, especially when you are trying to pick what data. Because if you look at the data, let's say Superstore. So let's say view Superstore. So if I run this one means view the entire table, isn't it? View the entire word table. But again, if I just type Superstore and I run it again, Superstore. So you see no objects. So is it Superstore, Superstores? Which one?
I think it's Superstores.
Now check how the spelling is. Super. Can you see this one? This one, it is exactly the way it is typed. That's how you have to bring it, because
Okay.
R
Yeah.
is case sensitive.
Oh,
R is case sensitive. So that why I suggest most times when he's importing everything to call whatever name he likes, but just take note, it's very case sensitive. Okay, it's very case sensitive. So if I look at the Superstore now, let's say for example, let's say I want to bring in category. I want to bring in maybe category and quantity. I want to bring category and quantity. So another way I would have done it, you know, instead of me using this select like this, if I'm not using the library, right? If I'm not using that library, but I want to just call them up. Okay, so what I can do, let's say, let me call df. DF. Now, in that case, I want to bring category and quantity. Category and quantity. What I would have done here is to have called superstore, then select category and quantity. I think that's how we normally do it. These are all that I've done. I'll just say superstore. You know, superstore, and then what? Select, and then select what? Let's say category, and select what? Quantity. So I just needed this to quantity. Okay, so let me run that now. So if I run DF, so this is what I would have had, isn't it? Okay, let me view it properly for you. View. So this is what would have had, is it not? Now, instead of going this route, another way of doing it is that, for example, especially where the data is not, the columns I need is not so much. Okay. So what I would have done is, let's say DF.
Please, put back to play.
So I'm going to now combine it.
It wasn't Chelsea they were supposed to play last time. Wasn't Chelsea?
Hello?
Please mute.
Hello, please can we mute? So now it means that when I'm now selecting, this $sign is to connect the two tables. So this is superstore category, Can you see that? Comma, superstore. I'll use the $sign now. Quantity. So can you see how I select columns now without the library? So this is how by default R used to select the columns. So you use what? The $sign. Okay, you use what? The $sign. So let's run that. Let's see. So let's say DF. So if I run DF now, can you see it now? Or let's say view DF. So can you see what has happened now? But the difference now is that you don't have to go and relabel these names. Can you see that? So if I say column names, if I just say names, DF. Can you see that it's say null because I cannot see any name there. Or if I say column names, DF. Can you see you cannot see any name? So that is the advantage of, so this one will just only select the columns for you, but without bringing it in that structure like the way you see it in the table. So that's the advantage of using this library over here. But if you just see briefly what is there, then that's fine. But that's why sometimes preferably you use this so that you bring it like your normal table. I hope that's clear. Is that clear?
Yes.
All right, good. So let me go into some other aspects. Let's go into some other aspects because you see, R in itself is actually used for what? Statistical analysis. You know, the statistical programming software, statistical programming. So basic for statistics. Okay. And if we remember in statistics, let me use another color so that I can see it. So if you see that in statistics, there are different things you want to do, you know. So in statistics, what do you want to do in statistics? Either I want to what? Compare. I want to compare. I want to what? Maybe find relationship. I want to find relationship, or I want to do what? Prediction. Or I want to do what? Prediction. Okay, so I either want to compare, find relationship, or what? Do what? A prediction. So I don't know if we can still remember our fundamentals in statistics. So remember in your statistics, remember there are two branches of statistics, isn't it? What are the two branches of statistics? What are the two branches of statistics? Yes. What are the two branches of statistics? Nobody remembers the branches of statistics. Data analyst.
Descriptive. I can't remember the other one. Descriptive.
Descriptive awards.
Is it inferential?
Yes,
Descriptive.
Yes,
descriptive,
yes.
descriptive and inferential. So if you remember that at this stage, when you are going into data science, right? Remember, you must have your domain knowledge, isn't it? You must know your domain knowledge. You must have understanding of maths and statistics. Then a bit of what programming, isn't it? So this is what you do as what data science or data what analyst. So you cannot escape this aspect of what statistics. Okay, so you must always understand. But let me just go over it again so that you just understand what statistics is about, right? So because if you look at everything has to do with what analysis of what the data, isn't it? And we mentioned that data in their natural form does not make any sense, isn't it? Until we need to what analyze it. Okay, so we can collect this data from different sources. Basically, there are two sources. What are the basic sources of data? What are the sources of data?
Primary.
We can
Primary
have
and
primary
secondary.
source or what? Secondary source.
Secondary.
You know, we can talk about what? The nature of the data. So when we talk about nature of data, what are the nature of data? Nature of data. What are they?
Time series.
Nature of data. Quantitative
And qualitative.
and what? Qualitative. Isn't it? Exactly. Remember, these are quantitative and what they call numeric. Why these are non-numeric or what they refer to as categorical. We can call them categorical data. Okay. Then we talk about the timing of the data, isn't it? The timing of the data. So timing of data, what do we mean? Timing of data.
Cross-sectional and
Yes, we have cross-sectional and what?
time series.
And time series what? Data, isn't it? Because remember, how you collect this data will determine how you are going to what? Analyze it. Okay? So you must be clear on that. That how you collect the data will determine how you are going to what? Analyze it. And what are the basic kind of analysis you are going to do? Is either I want to what? Compare, isn't it? I either want to what? Find a relationship, or I either want to what? Make what? A prediction. Okay. And when we collect this data, we present them either in tables or what? In charts. I think that's what we have said. Either we collect them in tables or we collect them in what? Charts. So for example, now, if I have two variables, for example, I want to check, is there a difference between the age of height in male and female? So this can be male, this can be what? Female, isn't it? This can be male, this can be what? Female, and this is the height. So what I'm trying to do, I am trying to what? Compare. Okay, I'm trying to what? Make what? Comparison. Or if I'm looking at what is the relationship between what? Height and weight. Height and weight. Isn't it? So I'm looking for what? A relationship. And I'm saying, oh, there's a positive relationship between what? Height and weight. Okay. Now these are the kind of analysis you may want to what? Do. So it means that when I look at the data, I can do some form of analysis in form of if it's numeric or non-numeric. So it can be numeric, it can be numeric data, isn't it, of variables. It can be numeric categorical, It can be categorical. Can you see that? So these are the, you now group them and say, how am I going to what analyze them? So for example, height and gender, what are the two variables? Height and gender, what are the variables there?
Height and gender.
Height and gender, is it numeric category? Is it numeric categorical, categorical? Which of the groups do they fall into?
It's numeric category.
It is what? Numeric and category. What about height and weight?
Numeric.
Numeric.
Can you see that? So sometimes these are the two. Just once you have seen them, then you now know this is how I'm going to what analyze them. Okay. And again, remember, for most of your categorical variables, the only kind of analysis, what differentiates quantitative from qualitative data? What differentiates quantitative from qualitative data?
Quantitative you can do arithmetic on it.
You can do what? Arithmetic what operations on them, right?
Yeah. Qualitative, you can't do arithmetic unless you want to count.
Except you want to do what? A count, or take a proportion, just to count and take the proportion out of the total, isn't it?
Yeah.
So that is the kind of analysis you are going to do in your what? Qualitative what? Data. Okay. So at the end of the day, what we want to do is to what? Summarize the data. So in statistics, we need to what? Collect that data, organize the data, present the data, isn't it? Analyze the data and interpret the data in order to make informed decision. So that process of us collecting the data, isn't it? Organizing the data and presenting the data without drawing any conclusion, it is what? Descriptive statistics. Isn't it? So what you are simply doing, you are only what? Summarizing the data. And how do we summarize it? How can we summarize data? By taking the mean, isn't it? Take what? The maximum. Take what? The average. Is it not? Take what? The standard deviation. All these are what? You can take the first quartile, the second quartile, the third quartile. All these are what? Summary what? Statistics. They are all summarizing the data without drawing any what? Conclusion. And take note, this can only be done for which data? Is it quantitative or qualitative data?
Quantitative.
Quantitative, only quantitative you can do this. Okay. And to further visualize this, we can use what they call a box plot. Have you heard of box plot? Have you heard of box plot?
No.
We have not heard of box plot.
Oh, we have.
In Excel, do we not go through it? Box plot.
We did.
No, scatter.
We have scatter graph. We also have box plot. Box plot is a visual representation of your descriptive statistics. Okay. So the last aspect was what they call inferential. So what is inferential doing? Remember that sometimes we want to study the entire world observation, isn't it? The population, isn't it? But we may never have all the data. So what do? We take part of the data, which is called what?
Sample.
Sample. So based on this sample, we will now use to what? Generalize. So based on the sample, you now use to what? Generalize or infer. Can you see the hence the name inferential? You are inferring. Okay. So based on the sample, you are now drawing conclusion for the entire world population. So that process is known as what? Inferential what? Statistics. Is that clear?
Yeah.
Because remember, because you are using sample, what you are simply doing, you are doing what? An estimate. You are using what? An estimate. Can you see that? And under the estimate, there are two types. You have what they call point estimates, and you have what they call what? Interval estimates. Point estimate is exact, but interval is within what? A range. So that's why you're going to be seeing confidence level. It's not lower confidence level or upper confidence level. Okay. And again, under your inferential, you have estimation and confidence interval construction, and you have what your hypothesis. Hypothesis what testing. What do we say a hypothesis is? When you say hypothesis, what is hypothesis? Yes, what is hypothesis?
Yes.
Okay, guesswork.
Okay, it's a guesswork, isn't it? It's a guesswork, okay. So it's a tentative statement which may be true or false, depending on what the statistical what analysis. Okay. So whenever we are looking at how to test the hypothesis, we are looking at what? The statistical tools. The statistical what tools we are going to be what using. Okay. And in selecting the tools depends on certain criteria. One of them can be in terms of the size of the data. Okay. And that thing can be the grouping of the data, of the population of the data. Population or what group. Now, if I say size of the data in statistics traditionally, if your sample size is less than 30, we say it is small. If your sample size is greater than 30, we say it is what? Large. Can you see that? So if it's less than 30, we say it's small. If it's greater than 30, we say it is large. Grouping or population, it can be one population, two population, or three or more population. Can you see that? So it can be one population, two population, three or more. It's just like, for example, I am trying to check, for example, the difference between what weight and height. So the hypothesis is going to be that what? The hypothesis will be what? The null hypothesis is going to be what? There's no what? Significant difference. There's no significant what? Difference. Can you see that? Because here is comparison, isn't it? In the what? Between the weight and height. Okay, let's say between the heights of what? Male and female. Can you see that now? There's no significant difference. That is why hypothesis test is also called significance testing. You are testing for significance. You see, even when we look at it like this, even here, maybe here is let's say here is 1.8 meters. Maybe here is 6 meters. We are saying, we're not saying there's no difference, but we are saying, is it significant for us to worry? Can you see that? But if one was 1.8 and that one was, let's say, 1.3, is it significant? Is it significant?
Yes.
Yes, it is.
Is it not? Good. But some, we see that, oh, there's no much difference. Isn't it? There's no much what? Difference. So we shouldn't worry. So either way, it doesn't matter. In the same way, if we're having 3 or more groups, so this is like, for example, 2. If we have 3, for example, you want to employ, you are recruiting, isn't it? Like HR, they are recruiting. And they are asking, does it matter which school the person comes from? Does it matter which school the person comes from? Okay. So let's say, for example, now you have maybe those in LBS, so graduates from LBS, graduates from Unilag, graduates from Uniben. Can you see that? This is 3 or more, isn't it? You now give them tests. So your hypothesis that the school that they attend does not matter, isn't it? So there's no significant difference. No significant difference. There's no significant difference in the performance. In the performance of candidates. Okay, of candidates from different schools. So if maybe LB, so out of 100, this guy scored 80. Unilag scored maybe 79. This guy scored
95.
maybe 95. Okay. Now, in terms of their performance now, right? Did all of them pass?
Yes.
Did all of them? Okay, let's do something
Once
so
they
that we
pass.
can understand, so that I can pass the message properly, clearly. Let's say this guy was maybe 82 or 83, right? 82 or 83 now. So let's look at it now. Did they all pass?
Yes.
They all passed. Does it matter which school they come from in terms of their performance?
Doesn't.
Does it
Not
matter
quite.
which school they come from?
Not quite.
Not quite, isn't it? So, which means I am giving them an objective test to check their ability. And from my findings, I'm seeing that there was no difference. So it means that even if I pick somebody from Uniben, his performance is not different from a graduate from LBS. If I pick somebody from Unilag, his performance is not different from somebody who finished from what? LBS. So which means there is no significant difference. The implication is that whichever school I take the person from doesn't really matter, because their performance is not so far. But if, for example, now, of all of them now, right? Of all of them now, let's say, for example, this particular person now scored maybe like 40 out of 100. 40 out of 100. Is there a significant difference now? Is there a significant difference?
Yes, there is.
No, the-
So once there's a significant difference, it means that what? The school that they attend matters. Can you see that? Now, that can now drive my policy that I need to now know the kind of school the person is coming from. Can you see that? So this is when we talk about what comparison. We are trying to compare, but what we are checking from is there a significant difference? Same thing with relationship. Is there a significant relationship? Is that clear?
Okay. Yes. Can I ask you a question?
Yes, go ahead.
Okay, when you were talking about this data set, if in statistics 30 data samples 30 and above is considered large, and the other one is smaller. So can we consider this LBS, Unilag, and Uniben as three populations?
Now, these are the population. Yes, these are the population or the groups.
Okay.
I can now have taken about 100 students. Can you see that? So on average, this is their performance.
Okay. I get.
I'm checking their average performance.
Okay.
Okay. Is that clear?
Yes, it is.
Okay, let me use, I think I have one Excel sheet that I try to structure it. Let me see if I can find it. So, okay, maybe statistical analysis. Let me see if I have it. Statistical analysis. Let me see if I can see it. Aha, beautiful. I've seen it. So let me share it with you guys. Yeah. So can you see my screen?
Yeah.
Great. Now look at this one now. So we have gender, we have age group, we have height, we have what? Width, isn't it? Now, if we look at this now, gender, what kind of data is this?
Qualitative.
Qualitative. Age group, what kind of data is this? Qualitative. Height, what kind of data is this?
Quantitative.
Weight, what type of data is this?
Quantitative.
Quantitative, isn't it? Good. Now, we said that when you look at it, for qualitative data, what kind of analysis can we do for qualitative data? For qualitative data, what kind of analysis can we do?
You can count.
We can count, isn't it? We can count. So here, if you are to count this now, how we have done this now? If you want to analyze this one, how we have analyzed it now? If you want to get something, if you want to get something like this, now how we have done it now?
Well, you count now. You count gender. You count the column B and the male. Count
So how we
count
do it? How I know you count, but how will you count now?
in Excel.
Yes.
Okay, it's count if. Count if.
Count if. Okay. So count if. So if you want to go through the formula now, what do
It should be count if you open the bracket and then
you don't want to? I
select-
don't want to use for. I don't want to use any function.
Can't
I
use
don't-
sort or is it filter?
Use
Okay,
what?
you filter. You filter.
We filter. Help me count. Data
You filter?
analyst. Data analyst.
Filter, you filter, you-
Wow. All right, so we just take now gender, isn't it? Gender to where? Rows, then to
Oh,
count.
pivot.
Is that not it?
Yes.
Or I can bring another one again there, isn't it? Then I'll now switch this one. I'll view as what now? This one, I want to view as what now? Show as percentage of what? Grand total, isn't it? So this is number, this is percentage. Is that not how we do it? This is gender. Right? So the same way, so those are how you can analyze quantitative, qualitative what data. But for example, male and height and weight now, height and weight, the only thing I can do is to find, I can put it in the form of a scatter graph, isn't it? And I can see the relationship there, whether it's positive or negative. So I can add a trend line, I can put display equation or what, the chart, isn't it? So these are the kind of things I can now do to check their relationship. Alternatively, I can also run equals to correlation. Remember the function of correlation. Let me pick this one, comma, pick this one. Aha, what did he say? Correlation of what? Correlate. Or is it because it's in a pivot table? Let's see. Correlates. Where's my array? So this array, comma, this array. All right, so that's the relationship there. So in that case, you can look at what their relationship. Okay. And remember again, what we've tried to summarize that when you are doing statistics, either I want to find differences, find relationship, or do prediction. But in doing that, I must be clear what kind of variable it is. Whether it's that will determine the kind of analysis I'm going to do. Whether it's categorical, I can use a chart, isn't it? Whether it's categorical, numerical, or numerical. Okay. But I can present them either tables using pivot tables or charts. And in selecting the chart to determine if I am comparing, finding composition, looking for relationship or what? Distribution. Because all this is going to guide you when you are doing your analysis. And remember, R is for what? Statistical what? Programming. So which means you must have some element of what? Understanding the what? Statistics before you start going into what? The R proper. Is that clear? So when we are summarizing, we can summarize using what? Descriptive statistics. Either we are doing the minimum, maximum, mean, median, proportion, and the rest. Okay. But this is what I was trying to explain in terms of what? The data, right? So we need to look at how to choose the statistical tool we are going to use. So if it's just a categorical variable, either one population or two population, we can use what they call chi-square. We can use what they call what? The chi-square, and usually it's for test for proportions. Whether it is one population or two population, as long as it's numeric, we can either use what? T-test or Z-test. Most times, right? Most softwares, you will see them use T-test.
But why they are using t-test, whether for large or small? So theoretically, when your sample is small, what do we mean? When sample is small, what do we mean by small sample size? What do we mean by small sample size?
When it is less
What is
than
less than 30?
When it's less than 30. So theoretically, they will tell you to use a t-test. When the sample size is large, we will now use what they call what? The z-test. Is that clear? But when the sample size is large enough, your t-test approximates your what? Z-test. They will arrive, you know that you get the same value, but you arrive at the same conclusion. Okay, so because the test will give you the same conclusion, that is why, to make life easier, they normally use what? The t-test. That's why in almost all softwares you see t-test. It is only a few softwares like Excel that you are going to see z-test. Okay, but all the others you are going to be seeing what? T-test. So that's why most times they usually use what? T-test to check for significant difference between what? Two what? Population. Okay, now when the population is 3 and above, we now use what they call ANOVA, analysis of variance. Is that clear? Analysis of what? Variance. So these are the tools you can use. So most times you see them either using t-test or they are using what? ANOVA. Okay, we'll share it. So you see them either using t-test or they are using what? ANOVA most times. Okay. Then again, if I have two numeric data, isn't it? I can now find what? The relationship, just like this. I can now find what? The relationship. Okay, I can now find what? Their relationship. But you see, when you want to test it, remember these are the rules. These are the rules. Generally, our room for error is what? 0.05. It's not 0.105. That's our margin of error, isn't it? Which means our confidence level is what? Our confidence level is what?
0.95. 0.95.
Which is 0.9, which is 95% what level.
Yes.
Okay? So when we do the analysis, it is going to calculate a value for you, which is called your p-value. So if your p-value is 0.01, I will now compare this value with what? This 0.05. So this is the rule. If this p-value is less than or equals to 0.05, what do? You are going to reject the null hypothesis. Reject what? Null hypothesis. But if this p-value is greater than 0.05, what do? We are going to what? Accept the null hypothesis. Okay? Technically, they will tell you do not reject. Do not reject means accept. Okay? So let's look at it. That example we gave, there is no difference between what? The heights. Is it not? Between what? Male and female. Between male and female. That's our HO. So how do we put it? We say there is no difference. So best practice, they put there is no what? Difference. Can you see that? There is no what? Difference. So if HO, there is no difference. What is H1? What is H1? H1 will be what?
There's difference.
There is a difference. So there is a what? Difference. So if we say reject HO, what does that tell you now? If you say reject HO, what does that mean?
That means there's a difference.
There's a difference. If we say accept HO, what does that mean?
There's no difference.
There's no difference. That's all. So once I look at this number now, I will just check. Is this significant? So am I looking for a significant difference? Am I looking for a significant difference or significant what? Relationship? Is that clear? So since here I'm trying to compare, I will conclude that there's no significant difference in the height between male and what? Female. If I say, is there a relationship between height and weight? And let's say, for example, my p-value was 0.53. When I compare with 0.05, what's my conclusion? What's my conclusion based on this p-value? What will be my conclusion?
Do not reject.
Which means that what? In terms of the relationship between height and weight, what is the conclusion?
Significant
There is, there is no
0.53.
difference. There is no. Wait.
Remember, the significance is that significant difference or significant relationship, right? Significant difference or significant relationship. So I'm looking for height and weight now. What is the hypothesis for height and weight? The hypothesis will be what?
The hypothesis for relationship will be,
Yes.
is there a relationship between height and weight? Like if you're
Look at it. See how I put it. There is no. You start like this.
okay.
There's no significant difference between
There's
height.
no.
and weight.
Now this is not difference. Now we are looking at relationship.
There's no significant relationship.
Relationship exactly
Between
between
height
height and weight exactly. So if I now have a p-value of 0.53, what's your conclusion? I have a p-value of 0.53. What's your conclusion?
It's greater than 0.05. So you accept your null hypothesis,
Good.
which says that there is no significant relationship between height and weight.
That is all you need to learn from it. So whether there's significant difference or that's all. Is that clear? So if I see another one, let's say 0.000, what's your conclusion? 0.000, what's your conclusion?
This is less than 0.05. So
Yes.
you reject the null hypothesis, and that means there is a significant relationship between height and weight.
That's all. Is that okay? Everyone, are we clear with this interpretation? Because when we go to R, because it's programming, you will see so many nonsense. You'll be wondering, hey, what am I looking for here? That is the only thing you'll be looking for is the p-value. That's all. To draw conclusion. I hope that is clear. So this is just an overview of what we are going to be looking at. Okay, so this is why R is more for statistics in itself, right? It doesn't mean that you don't do all the same thing in Python. But for core statistics, this is what we are going to be doing. Okay, so let's go back to R. Let's go back to R. Let us show what we have been doing. Let me see. Okay, I think I have, let me see. There's one data, did I send one data to your hypothesis? Do you have that data called hypothesis? Hypothesis.
I don't have it.
Okay, let me try and send to you guys now. Hypothesis. Let's see. Let me see where I kept that file now. Hypothesis. Statistical analysis. No. Hypothesis testing. Good. I've seen it. So what I'll do, let me first put that data for you guys. So let me close and send it to you guys.
So when we move to hypothesis testing, create copy. All right, great. So let me please on send to you guys now. So if anybody sees on the chat box, please share to the others who can find it. Put it on the desktop. All right, so are we seeing it now?
I've seen the hypothesis.
You have seen the hypothesis. Okay, that's all right. Good. Okay, so let's start with. So let's look at. So can we import that? We know how to import that data now, right? Do we know how to import the data? So can we import the data now? If I was to import the data now, what file is it? What file is it?
Is an Excel. Excel.
It's an Excel file, isn't it? It's an Excel file. So it means that what library am I bringing to? But since I brought the library before, but remember, what's the library? What's the library for me?
Read Excel.
Read what?
Read Excel.
So library, read Excel. If it was a CSV file, it would be what? Read out. But once I've run it once, I don't need to run it again. I'll just call it. So let's say, for example, okay, let's say AB. Let's say AB. So read what? Excel. Okay. Let me paste my parts there. Now, if you know that Excel file, remember I will have to change all this. Remember that you have several sheets in Excel in that sheet. So which sheet? Let's work with the first sheet. So that first sheet, what's the first sheet called? Where we have the analysis. Let me check the data.
Statistic.
No, that one, there's no data there. There's no data there. That's just a summary.
Okay.
Okay, let's look at t-test. T-test. So t-test. So see t-test. So the name of the sheet is called t-test. By default, it will bring the first sheet for you, isn't it? So we want to bring in the other sheet. So we say comma sheet is equals to what? T-test. It must be exactly how it's typed there. Otherwise, it will give you error. Okay, it must be exactly how it is typed. Okay, it must be exactly how it is what typed. Okay, so let's run that. So let's say view AB. Let's check. Did it work? Yes. So can you see that now? Okay. All right, good.
So let's say, for example, now there's a new product or there's a new training that you have given, isn't it? Or a new intervention. But you want to now find out, is there an effect or is there a difference in how they perform before the intervention and after the intervention? Okay. So in that case, you are looking for what? Difference, before and what after. Is it not? Before and what after. So whenever you have data, the first thing you want to do is to do a descriptive statistics, which means descriptive statistics has to do with what? When you are describing your data, what does it mean? Descriptive statistics. It's simply what?
You're summarizing it.
Summarizing the data. You hear the word summary, isn't it? That's the same way you do it. Say summary AB. Can you read this one now?
Yeah.
What are the things you are looking out for?
Mean, median, the minimum, the maximum.
The minimum, the maximum, isn't it? Good. Now, if I want to put this visual graphically, which chart will I use?
I use box plot.
I'll use what? The box plot. I'll use what? The box plot. Okay. So there's a function called box plot. Box plot. Okay. Box plot. Now, I want to select. Remember, I have before and after. Those are my columns. So my columns is before and after. So what do? I want to select the columns before and select the column after. How do I select it? Before and after. How do I select it now? I want to select the two columns before and after. How do I select it?
It will be and.
It will be what?
It will be before.
Before and after. Is that? I want to select the columns before and after. Let's look at the data again. Look at the data. I want to select before and after.
Do you do range?
Range. Range may not pick it now. It will bring them as one, but I want to bring them as separate columns now. Before and after.
Can you call the data then, select and then select after?
So now you want to use select, right? Now I showed you another method. Instead of using select. So you use, for example, AB, that is the data, isn't it? Do you prefer I use AB or do you want to call it data? Which one do you prefer?
I use the AB.
Should I call this one data so you know that it's data we are talking about?
Okay.
Would that one be better for you?
Yes.
Okay, so let's run that. So if I say view data, so this is data, isn't it? So now I want to select the columns now. So what are the columns? So if I type names, data, so can you see that we have gender, we have before, we have after. So what I want is what? Before and after. So what do I do? Data. Can you see that now? That $ is one and that gives you access to what? The columns. Do you remember this?
Yes.
Comma, data. Can you see that there are different ways of doing the same thing, but one method will be more efficient than the other method? Where I want to select a large data, I would have just used that library instead. But where I want to select specific columns inside the function, then this is where this method will be better. Is that clear now? So before, after, isn't it? So let's run this and check. So box plot, let's see how that box plot will work. Can you see that now?
Yeah.
Can you see that now? But now, let me put But you can label it. If I put all the labels now, it looks scary. Okay, let me label it. So for example, I want to put my Y label. So Y label, so it will be Y label equals to what now? Where's my Y? My Y will be the score, isn't it? Comma. My X label will be what? The groups. Let me run that. Can you see that? So this is the group. These are the scores. Can you see that? If I want to put a title on it, I'll call it main. Let's say before verse after. Okay, let's say sales or whatever intervention we have there. Can you see it now? Can you see what it looks like now? So with R, you can customize it as deep as you want. But since we have not got into visualization in itself, so I will not go deep into it. But I'm just showing you how you can now check. But looking at it virtually, is there a difference?
There is.
Looking at it virtually, is there a difference?
There's a difference.
Is it significant?
For me, yes, it is. It does.
For you, yes. Any other person saying that it's not significant? Yes, now you can visualize in R now, yes. When we'll come to data visualization. I always tell you now, when you look at the tools, when you talk about extraction, analysis, visualization, you can also use Python and R to do visualization. If I want to get to, we can even build dashboards, just like you have your dashboard in Power BI, you can build dashboards in R. You can also build dashboards in R. Just that it looks like only programming, there's no user interface that you can drag or drop. So if you wonder how you do it, yes, it's very possible. Okay, good. So let's look at it. So is there a signal difference or not, based on what we can see here? Is there a significant difference?
It looks like there is.
There is, right? So what you are saying here, this is the minimum, this is the maximum. Minimum, maximum, isn't it? This is the average. Minimum, maximum, this is the average. So on average, so what you are comparing the average. Is there an average difference? Okay, so let's check it out. So to do this, what kind of test are we going to do? What kind of test are we going to do? We are going to do what? A t-test. We are going to do what? A t-test. Okay. So let's say, so let me say T. Let me just call it T. What should I call it now? Okay, let me just leave it as A first for now. Okay. So the function is called t-test. So there's a function called t-test. Can you see that? So we can now put the data. So we have before, we have after. Okay, we have before, we have after. Okay, what's the data? So data is equals to what? Data, I think. So let me run this and check. Before and after not found. So if it's not reading it this way, then what we can now do is to now call the data. Can you see that? We can now call it data. So in that case, maybe I don't have to call data anymore. I will not have to call the data here. Let me run this and check. Okay, good. So if I run A now, what do you think will happen? If I run A now, what will happen? Does this make sense? Does this make sense?
Yeah, I can see the p-value there.
What's the p? So what's your conclusion?
The p-value is low. I think it's lower than 0.05. Yeah. So that means there is a significant difference.
Everybody, do you agree with that?
Yes, I do.
Yes, yes.
So virtually we have seen it. You have agreed there was a significant difference. Now it is confirming it statistically. Can you see that now? Okay. So I told you that once you run it, it will give you so many numbers there, right? Just what to look out for, isn't it? You know what to look out for, and that's the keyword value. I hope Snowball is reading it as 1.92. Is anybody reading it as 1.92? Is anybody reading this as 1.92? 1.129? Is anybody reading like that? Yes? So nobody? Okay, all right, great. So I hope this is clear now. Is this clear?
Yes, sir.
All right. Great. So which means if there's maybe anything that you are doing maybe before and after, so maybe there's a new advertising this campaign you have brought, you know, so you can say before and after. So before we introduced it and after we introduced it. So now we want to check if there's a difference. But if there's no difference, what is the implication? Should we go for that campaign or not? Let's look at from a business point now or strategic point now.
There's no difference. There's no point going for the campaign.
Beautiful. So if there's no difference, it means there's no point wasting money for that what campaign. Because there's no difference between when there was no, that campaign was not there and when it's there. But if there's a significant difference, can we go ahead with the campaign?
Yeah.
Exactly. Can you see that? So it's just simply showing that the after sale is way higher than this. Clear? Is that clear? So in as much as data analysts, right, we must also understand how we can apply it in business sense. Because ultimately, this is what will help management or drive our strategic decisions. So it's not about this campaign is going to boost sales. You need the data to prove it for me statistically, isn't it? So doing this type of analysis is what will help make your decisions more data driven than just have an opinion. Sometimes you see with your experience, you can explain why it's going to have significant effect, isn't it? But sometimes if you have the data and without your experience, you see the way you're going to convince people will be much more better and much more scientific and logical. Is that okay?
Yeah.
So let's go to the next one. Let's go to another one. Let's import the other data on ANOVA. Let's import the other data on ANOVA. Let's look at the other data called ANOVA. So let me import ANOVA. ANOVA. So I'll still call it inside data. Besides that ANOVA spelled. Is it ANOVA? Aha. Okay, good. So I'll still put inside data. So let me say view ANOVA. Let's say view data. So can you now look at how it's grouped? Do you see how the data is arranged? Do you see how the data is arranged? Instead of me having method 1, method 2, method 3 on different columns, I will have it in one column. Because remember our rule, all categories must be in what? A single column. Do we remember that our rule? All categories must be in a single column. I hope we have seen that now, right? All right, good. Let's go. So data. So if I run data, can you see them now? Data. So this is the data, isn't it? So I have method 1, method 2. How many methods do I have there? So let me say column names data. So we have group and score. Okay, group and score. All right. Group and score. Okay, good. Now let's see how we can analyze this, right? Now, if I want to do this, so if I look at the data in itself, right? What will be my hypothesis? What will be my hypothesis? What will be my hypothesis? Yes, what will be my hypothesis?
But they have significant relationship. The method 1 and method 2 have significant relationship.
Significant what? So let's look at it.
Relationship.
Let's run it and check. So we have method 1, method 2, and their score. So what are we looking out for here? There is no difference in the method, is it not? No significant difference in the what? Methods.
Method.
No significant difference in the what? Method. So if you look at that data, we have method 1, method 2, method 3. Isn't it? So we are comparing among what? 3 methods. So take notes. If you check how we have analyzed it, right? The first one where we are doing before and after, you will notice we had before, we had after. Now in this case, since we're having more than, what do? We now put it in this structure. So we're now comparing the difference between method 1, method 2, method 3, isn't it? Can you see that? So we're now comparing the 3. So if we have comparing within 3 methods, put it in this structure. If it is just maybe, for example, just to before and after, we put it in this structure. Can you see that? So when it's just 2, it is okay to put it like this. But when it is 3 or more, is it not? When it's 3 or more, it is best that we what? Put it in this word structure. I hope that is clear.
Yes, sir.
Take note of that. Take note of, because how you structure it again will determine how you are going to what? Analyze it. Okay. So now so the data is already inside data. So let's look at it. So let's call it ANOVA. Let me call it ANOVA. So AOV is analysis of variance. So the function is called AOV, analysis of what? Variance. So remember, I'm trying to compare between what the group and the score. So what's the score? So I'll put the score. So that's the score. I'll now use this symbol here. No, this one. Score and what? The group. And the group. What's the data? Data is equals to what? Data. Data is equals to what? Data. I hope you understand what this one means. Because you see, in the argument, you have what they call data. So, but the data is called data. So this data is this data here. But this data is the argument. So let me run it now and check. So look at it. This is the function. So if I write AOV stands for what? Analysis of what? Variance. So can you see how can you see formula? Can you see the formula? Which is this one. Can you see data? This is data. Equals to what? The data here. So you now fill it, put the data there. All right, good. So let's run it now. Error in what now? Group. So let me check now. Let me see how it's spelled. So let me run that and check. So group score. Okay, group and score. Okay, group and score. So score, then group. Let me run this and check. All right, good. So the way it is spelled, that is exactly. If it's small letter, type in lowercase. If it's uppercase, you must type it the way it is on the data set. Okay, good. So it's as if that when I have run ANOVA, let's run ANOVA and see now. Can you see this? Can you see this now?
Yeah.
That's brought another set of data, isn't it? Now, instead of you running it this way, and that you'd have done just a summary of what? ANOVA. So use summary of what? ANOVA. Let's run it now. So this is how ANOVA table will actually look like. Okay. So what is your conclusion? What is your conclusion?
There's a
What is your
Then-
conclusion?
forget
In
to
conventional, there's
F value. Now it doesn't show significance.
What is your conclusion? So we have different methods. Maybe we want to look for which method can we use to improve our sales. So we have social media, we have TV, we have ads. So those are the 3 different methods. So we are saying that, oh, there's no difference in whichever method we are working in advertising. Okay. Now we have carried out the analysis now, isn't it? So what is your conclusion? Is there a significant difference in the method or not?
Is that PR the same thing as P value?
PR stands for what? PR is what?
I'm asking. I don't-
PR, that's probability now.
Okay, probability.
And what is P value?
Probability.
Probability. So based on that, what's your conclusion?
There's a significant difference.
There's what?
A significant difference in the method.
Do we all agree with this? Do we all agree with this? Do we agree there's a significant difference? Okay, okay. Great. So even that is programming, isn't it? You see how it's very it's not like user friendly, is it not? So it just brings everything. If it was in Excel, at least I put it in small table. But here everything just looks like coding. But it's for you to know what you are looking out for. So in all these numbers is giving you just only one number you are picking out. That's all. Just this number. That's all. But you see, to further check it out, let us put it in form of what? A box plot. Let us visualize it. So let's say box plot. So what's the distance? So data. So let's say data what? Score. Data group, isn't it? So let's say my X label. What's my X label? My X label will be what now? Let's say the methods. The methods. Okay. Then let's say my Y label is what? So let me bring it down so you can see it. My Y label is what now? Let's say the scores. Or it can be scores or it can be sales or whatever. Okay, let's call it sales. Okay. Then let's say the main heading will now be what? Let's say sales by what now? Advertising methods. Or is there another way we can put it?
By medium.
By medium, sales by medium. Sales by medium. Great. So let's put the box plots. What did he say here? Let me miss anything there. Let's see. What is one? Let me see. Why is not plotting it now? Okay, let me clear this one first. But it's supposed to have applied. Let me see. Box plots. Error where? in box plots. Check, did I miss any spelling out? So that's the box plots data score. Okay, what I would have done here is to use this. Okay, so let me run it now. Since it was for group, did it come out? So data, X label, method, Y label, sales, me. Did I close brackets?
No.
I didn't close the bracket. Okay, let me see. So that just relates, you just have to be careful with it. Let me run that and see. What is this saying now? Okay, let me put a comma there and see if this will work now. So error in what? X floor and ceiling. Non-binary loop. Oh. Let me see. Now you know why it's a bit different, because it's the way the data was structured. You know, when we use for t-test, there were 2 columns, isn't it? But now everything is inside 1 column for group. For that's your methods. So I think that is where the issue is coming up. Aha. So that's it there. So can you see it now?
Yeah.
Great. So take note, the difference between what we have done now and what we did before. So if you see the first one, we just only had 2. So that's why we had to put comma. Can you see that? Because they were on 2 different columns. So that's why when we ran it using this thing there. Why does it appear again? Let me run that again. Okay, this data, because this one we called it something else, that's why. So let me, okay, don't worry, because we use the same data, that's why. So you cannot see any data like that. But the point is that when we are using t-test, it was 2 separate columns. That's why you have to put comma. But this group, because in the method, we had to watch all the different methods were inside 1 column. So that's why we have to use this word, ellipse key sign there. Okay. Otherwise, I would have used comma if they were separate columns. So this is what you are seeing here. So visually now, is there a significant difference?
Yes.
Is there a significant difference?
Yes, there is.
There's a significant difference, right?
Yeah.
Now the question now is that if you say there's a significant difference now, so which method will you now take?
Method 3.
Method 3.
Yes.
Is it not? Method 3. So it means that, so if this was maybe, let's say this one was social media, this was,
TV.
Which one?
TV.
TV. Then this one was what now? Let's say this one was radio and advert or whatever. Radio advert. So it means that this is the method that will be more significant in increasing our sales. Can you see that now? So looking at it using the analysis itself, because in all this one, this is a way of looking at it visually, but assuming this, we did not plot this chart, how can we have known which method would have been more significant? Because remember, if you have run this is the result we have had. So if I want to do this mathematically too, we want to now check which method, is it not, is causing the difference. Which method is causing what? The difference. So we do what they call a post hoc test. It's called what? Post hoc test. Post hoc. Post hoc is now to check, okay, if there's a difference, where is the difference coming from? So it's now called a post hoc test. Okay. So there's a method called, they call it HSD. HSD simply stands for, HSD stands for honestly honestly statistical or honestly significant difference. Honestly significant difference. That is HSD. Okay, so you have different methods. Okay, so you have what they call the Tukey tests. So these are the common tests that you can use. Okay, HSD. So HSD stands for, so if I hear Tukey HSD, can you see that? Tukey HSD. You see why R is for statisticians? Is strictly for what? Statistics. So this is where R has its own benefit over your Python. So when I want to do some kind of statistical analysis, it's not that you cannot build it in Python or you cannot do it in Python, right? But R is more suited for that kind of what? Analysis. So this is where you see data scientists, right? Or you say you are a data analyst. That's why you see most of them want to use what? R, especially when they are carrying out statistical what? Analysis. So this is the advantage you have of R over Python in this sense. It doesn't mean that you cannot do it in Python, but this is what more easy to what? Use. So here, I'll just say Tukey HSD of what? ANOVA, isn't it? ANOVA. That's where we have the result of ANOVA. So let's run that. So can you see the result now? Can you read it now? What is it saying? So this is the difference. Method 2, method 1, method 3, method 1, method 3, method 2. So we are using the p-value. Can you see the p-value now? So interpret this now. What do you have here? Interpret this. What do you have here?
0.93.
What does that mean? What does that mean?
Not significant.
No, so that means there's no significant difference between what? Method 1 and method 2. Does that confirm this here?
Yeah,
Yes, it does.
Go to the next one.
there's a difference.
There's a difference between which method?
3 and 1.
Method 3 and
And
method 1. Go to the next one.
Difference.
There's a significant difference between what?
Method 3 and 2.
Method 3 and 2. So therefore, where is the difference coming from?
Not 3.
Method 3. Can you see this is how to do it statistically? This is how to do it virtually. So this confirms that what? Method 3 has what? The effect or what? So it's the one we should go for. Can we see that? Because that's the one that will increase our what? So that's the one that is most significant. Are we clear?
Yes.
So the same way with, for example, if you assume it was a test that we have given different students, we have given tests to different students. Let's say this one was from, let's say UNILAG. This one was from UNIBED, and this was from LBS, isn't it? So based on this one, who will you go for? Which school should we go for?
LBS.
LBS, is it not? So this one is now what will drive your decision why you are going for what this particular word. Your experience would have shown, you'd have already known it, isn't it? That LBS, but you don't want to back it what statistically. Okay? You don't want to what back it what statistically. Okay, so that's how we go over it and analyze the data. I hope this is clear.
Yes, sir.
All right, good. So I think we can end it here. So when we come back next week, we shall. So I'll just do maybe chi-square, then we'll enter regression. So from there we'll try to do. Okay, I'll still teach you some other things, but most likely we will enter machine learning with R next week. But I'll first of all cover the basics of regression and correlation in R. For those of us who attended our Python session, you will now start seeing the differences. Okay. But please go through over this again and practice, especially when you're looking for what differences. So this is how it works. All right. I hope this is okay.
Yes, but Can we have the commands that you have typed?
Oh, the command. So should I? Okay, let me copy them out. Let me copy them out. Okay, let me copy it out. So do I paste it? I'll paste it here. Oh, it's too big to paste here. It's too big to paste here. Let me see. Okay, let me put it in a. Let me put it in a text file. Let me put it in a text file. So this is R code. Okay, good. So let me share that on the chat. All right, that's it on the chat now, so you can easily follow it.
Okay.
You have the data set now, right?
Yes, I have it.
So that's the code there. Good. So somebody should share it on the WhatsApp group also, so just in case. Somebody should share on the WhatsApp group. All right, guys, thank you very much, and enjoy the rest of your weekend. So see you next week. All right, thank you. But please try and practice. Try and practice, so because R is a little bit, it's not as user friendly like the other ones you have been doing.
All right.
That's why you see some organizations. That's why you see when they want to combine and combine Tableau with R, Power BI with Python. Okay, so just for you to just have a balance of which tool you want to use. So just practice them. All right, guys, take care and see you next week.
Thank you.
All right. Bye. Thank you.
Bye.